Okay, so just remember, what are the distributions that we look at in this course?
Normal.
Yep.
Binomial. Poisson.
Yep. There was also one other one that we did start with. I can't remember whether I did it with you formally or not.
Uniform, I think.
Yes, good. So that was the one we started with. We started with uniform. And that was just simply the distribution whereby all of the outcomes were equally likely. Okay, so the classic example, rolling a dice, right? So binomial, we then had Poisson, which we've just done, and you're right. The other one was a normal distribution. So these are the only 4 that we get asked about. I'm going to put uniform in brackets on the basis that we don't get asked anything in the assessment. So it's not strictly speaking on any of the assessment learning outcomes, okay? These 3 are though. So the binomial and Poisson are both examples of discrete distributions. The idea being is that they can only have specified outcomes within any given interval, right? So for example, if you're talking about binomial distribution, the example we used, scoring goals. You can't have 9.75 goals, right? It doesn't make sense. You can only have 9 or 10. Same with Poisson. You know, we were talking in this case about number of people admitted to hospital. Again, you can't have like half a person unless they are really badly injured, I guess, but you know, let's not worry about that, right? So in which case then, a normal distribution is a what? So if we've got discrete, what's the other one? Begins with a C. Con.
Oh, continue having.
Yeah.
I thought you wanted
No, that's fine.
like exponential.
Oh yeah, no, don't worry about that. So yeah, no, that's fine. So in this course, we only look at these 3. We have binomial and Poisson, which are discrete distributions, okay, and normal is a continuous distribution. And actually, these 2 distributions, both the binomial and Poisson, if you look at their probability mass function, they are literally following exactly the same shape as a normal distribution, except for the fact that they are discrete. They have bars instead of just a nice smooth curve. But basically, as n approaches infinity, so once again, as we get bigger and bigger samples, then actually it should be the case that it all tends to a normal distribution. Okay, so normal distributions are really the king of all the distributions, I guess. There are other types of distributions out there, which, for example, what's the survival one? Kaplan-Meier, right, for example. So there are other distributions that situations follow better, but in general, the vast majority of things in life will be normally distributed, okay? So with the extremes on the outside and the majority of data in the middle. So, given the fact that we've just looked at binomial distribution, a Poisson distribution, the next question is talking about can you understand and can you interpret what a normal distribution is doing? Now, of course, just be aware, one final point to sort of, labour here. With a discrete distribution, so either binomial or Poisson, we can work out exact probabilities. You happy with that? Right, so we can actually work out the probability that x is equal to some particular value, right? As well as the less than or the greater than probabilities as well. With a continuous distribution, it's much harder to do that, okay? It's called a likelihood, and we can do it, but we tend to look at it in different contexts rather than from the perspective of, okay, I want to work out, can we work out this exact probability? Generally, with continuous distributions, particularly the normal distribution, we tend to instead look at the cumulative probabilities instead. So either probability that x is less than some particular value, or probability that x is greater than some particular value instead. So not the x is equal to, we're less interested in that. Okay. Also, just be aware that it could be less than or equal to, because it's continuous is the same. Okay, and the same for greater than or equal to. So whilst it matters up here whether it's less than or equal to, it doesn't matter down here. Okay. Okay, so that's just a little bit of revision of distributions. Now let's have a look at a question. So we basically have a shop that sells a certain type of chocolate bar. The chocolate bars are known to be normally distributed with a mean of 150 grams and a standard deviation of 5. First of all, let's define this random variable in this distribution. So, what we're going to say x is defined as. So what are we talking about if we're thinking about grams?
I mean, it's mentioned explicitly in this case that it's normal distribution.
It is a normal distribution, but I'm asking for, just in terms of words, how are we going to, well, what's x going to represent?
Oh. Well, and 150. Oh. I don't understand your question, sorry.
Okay, so that's fine. So have a look at so basically before we get into the n is distributed, what's the mean, what's the standard deviation, what I'm going to get into is what does x actually represent in this case. So I don't want to keep writing out this kind of sentence every single time, so I'm just going to use x to represent that.
Weight.
Good, weight of the chocolate bars, yeah? So x is going to be, it's all right, weight of the chocolate bars. Okay? And then we can get into, okay, so in which case the weight of the chocolate bars, which is just x, will be normally distributed. What's the mean? Yep, 150. Now what goes in the next space? What's the next parameter in this course?
Error.
Sorry?
Error.
Standard deviation or variance?
I think it's variance.
In this course, yes, it's a variance. So if the standard deviation is 5, the variance will be 25 or 5 squared, it's up to you. So yeah, just that's a little point which I remember making to you, but I will just remind you just now. In this course, we deal with the variance in the second position. If you open other textbooks, or if you go to other courses, for example, they will be talking about the standard deviation in that second position. In this course, it's always variance, okay? So if you see any number here, it's always taken to be the variance. Okay, so let's actually have a look at question 1, and then we'll take a break. So in question 1, we've been given that Alex buys a chocolate bar with a weight of 160 grams. Is this chocolate bar an outlier? Can we justify a reason for this answer? So what do you think? If I go into a shop, given that I know that these are how my distribution of my chocolate bars should be, or the weights of my chocolate bars should be, and I pick up a chocolate bar that weighs 160 grams, based on this distribution, can I determine, or how do I determine, whether it is an outlier or not?
I guess it's how you define what outlier is, I guess, but...
Okay.
Yeah. I mean, I think because it's only one mark, I think it's just you decide if it's standard deviation boundary or variance.
Good.
From there on, you say if it's nothing or not.
Yeah, good. So you need to think in terms of the standard deviation of this curve. Literally, if I draw the distribution of this out, I can draw it. It's going to follow a normal distribution. So there's my normal distribution curve. If I fit underneath, these are going to be my weights, okay? And then obviously on this axis, I'm going to have the probability of each of those things, okay? But these are going to be my weights. These are going to be my, what my weight is. So what goes in the middle of this curve? Yep, which is in this case 150. And if you remember, I know how this curve is distributed according to standard deviation, right? In other words, I know that if I go one standard deviation out each side of the mean, I think that's about 66% of my data, if I'm remembering rightly. So in other words, one standard deviation each side, given that my standard deviation is 5, should go to 155 and 145. Happy with that? Okay. Then if I go another standard deviation out each side, so this side and this side, I go another standard deviation, I should have, I think it's like 97% of my data, if I'm remembering that rightly. So that should be 160 and 140. Then if I go one more standard deviation out each side, so to here and to here, so that's 165 grams to 135 grams, that should be, I think, 99.7% of all my data. And actually, I can go out another half a standard deviation each side, but to be honest with you, in this course, we tend to say that as as long as we understand that the vast majority of our data, so between 3 standard deviations each side of the mean, so the mean plus or minus 3 standard deviations, okay, that should equal 99.7% of all of our data. In other words, pretty much all of our data, all of the different possible weights of our chocolate bars should lie within 3 standard deviations of the mean, okay, it's both above and below. So in this case, we're being asked for about 160 grams. So if you think about it, 160 grams lies right here, okay? So 160 grams lies within those 3 standard deviations of the mean. In other words, yeah, I think that's a perfectly reasonable value to get. Clearly, if I was getting something like 170 or 180 or 190 grams, that's outside the 3 standard deviations of the mean, so it's much less likely that this outcome is as a result of this distribution, okay? So it's more likely that it's an outlier, in other words, okay? So quite literally, the way which I want you to understand outliers in relation to the normal distribution curve, so an outlier basically lies more than 3 standard deviations from the mean. So in this case, 160 grams, which is the value we're looking for, doesn't lie more than 3 standard deviations from the mean, therefore it's not an outlier. So I just need to put that into words, okay? But in general, if I give you a question in the exam, this is how you want to answer it, okay? Think about 3 standard deviations each side. And in fact, if you look at your normal tables only go up to 3.5 standard deviations each side of the mean. And if you actually look at those distribution tables, you've got pretty much 100% by the time you get 3.5 standard deviations, right? I think it's only like 0.15% or something silly like that. Okay, so basically I want to use the cutoff of 3 standard deviations. If it's within that, in that range, it's not an outlier. If it's outside that range, it is an outlier, okay? So in this case, it's not an outlier. But obviously you need to justify as well. Okay, fine. I've done enough talking for 1 hour. Okay, does that all make sense, first of all?
Yeah, the only concern issue I thought was it could have been in the 95% threshold, you know?
Okay. Okay, that's fine.
I thought it was maybe an outlier because
sure.
like, it's kind of far still, you know?
Sure.
It's like 97%, right?
Yeah, so 97% is up to 2 standard deviations each side of the mean.
Yeah.
So 66, 97, 99.7. Yeah.
If we did a test of 90 or 95, it would have been an outlier, but
True.
it's not in this case. But that's why
True.
I wasn't sure
No.
about outlier definition there.
I get that. No, that's totally fine. So yeah, when we're usually doing hypothesis tests and stuff like that, I completely get it. We usually say, okay, if it's 95%, it's either 5% up here or 5% up here, or 2.5% each end, right? Yeah, so I completely get it from that perspective. But in this case, I think we can be pretty sure, right? If we use the 3 standard deviation cutoff or threshold, we can be pretty sure. All right.